Michael Abshoff is giving a very informal tutorial demonstration and talk about the ultimate tool for finding memory leaks and other things, which is it's much better than print statements.
Well, yeah, I hope you get the reference. It's like one of the most famous articles in computer security was smashing the stack for fun and profit.
Well, I think it predates that. I mean, it's the fast Fourier transform for fun and profit, right?
I thought it was Mark writing classical fun.
Well, we can look it up on Wikipedia and just.
I'm pretty sure it was the fast Fourier.
Well, I was hoping that the first slide would go over without without discussion. We won't go back to it.
We all down.
Like Martin's talk, like YMPQ.
Yeah, you have an argumentative crowd, I think.
I'm running this show. Valgrind on C or C++ code is pretty easy to use, and well, running it is very easy. Interpreting the output is fairly easy. Then actually catching the issue and finding the particular fix is fairly easy with a little bit of experience. We're actually Valgrinding Python, and Python has not only its own malloc implementation called pymalloc, which very, very much confuses Valgrind, and also in addition, it leaks about half a megabyte. If you start a Python session, you quit it, it leaks about, or it does not properly deallocate about half a megabyte of memory. And this has to do with the way internally how Python does reference counts and so on, i.e. what we call the dictionary problem, which we haven't found a solution to because we really don't understand the problem.
But if you're killing a process, you don't have to deallocate any memory anymore, right?
No. Well, the thing is, if you do not deallocate memory, it doesn't really matter because once the process is terminated, the heap is destroyed.
It does matter in this case.
Well, it doesn't matter if, like, from a perspective of it doesn't leak memory, but the thing is, there's like literally 13,000 not deallocated objects. So what you end up with is a log file of 1.3 megabytes.
It's too hard to find the memory.
It's the noise, signal to noise ratio. So and you can't just diff it. If you would just diff it, I mean, who cared? Because then you would look just what changed between the.
Why can't you just diff it?
Because it prefixes the PID, which you can actually remove, but also. Python doesn't run the same from one session to the next because the garbage collector might be invoked at different points and so on. I mean, at least that is my experience.
Could you at least separate out stuff that was allocated by pymem-malloc and by normal malloc, maybe? Because Sage often uses malloc.
The thing is what Valgrind does, it LD preloads malloc. So even if you call Sage malloc, it's not going to. I don't think it shows up in the call trace. Either because it's it's also, that's the next problem. If you start to optimize, all kinds of stuff is inline and so on. So even O2 makes the understanding of the call trace much more difficult, which you're going to talk about later. Because what I would really like is an O0 and G in the especially in the CLIP and all the other stuff that we compile.
Yeah, that's a good idea.
We use it. When I initially started this.
Wait, half your audience is confused about the answer to the question. No, I mean, it can be informal.
Right, I mean, so Nils was saying this is, the issue is really that Valgrind does not understand exactly what's going on with regards to Python and its memory allocation system, right? Like,
no, that can be fixed.
Oh, okay.
It's slower and, well, these runs that I'm showing right now, we don't care about the Python stuff. We just ignore it. And if you know what to look for, because this is the interesting bit. Initially, if you do /sage and quit immediately, you would get a 5 megabyte log. It would be like 30 or 40,000 issues detected memory-wise. Now we're about down to 1.3 megabytes and about 13,000 issues, and we no longer definitely leak memory because we fixed all those. That's like the easy hanging fruit. What we're now getting into is the more subtle stuff, and specifically it seems to be a problem that the sparse linear algebra leaks memory, despite William fixing a couple of things, I fixed a couple of things, and also Martin and Boken fixed a couple of things. But we still have definite memory leaks. And IFTY's example, it used to eat half the memory on Sage Math in a day. And now it eats like 10% of the memory in 7 days. So before Sage 2.3 or no, 2.8.3 or whatever, it was like running IFTY's program on any kind of machine. It was like a denial of service attack. Or anything involved sparse linear algebra. And
but his wasn't. His was half of his problem was exception handling involving or signals and comparing equality and inequalities of Perry objects. So it was like something involving the Perry C library
I think
and signal handling. That was like half. That was a big chunk of his problem. And then there was sparse linear algebra, which is another big chunk of his problem.
Yeah.
So there are a lot of issues that Valgrinding uncovered that would have never been uncovered otherwise.
Yeah, the
so
thing is,
easily.
if you have like if you start using Valgrind early on in the process, you obviously catch the issues early. Now we pretty much have like 160,000 lines of code or whatever, and if you get into it after 2 years, I mean. The thing is, I pretty much Valgrind anything I touch. I mean, everything. There should be a lot of embarrassed people, which I don't name publicly. Well, not no. I mean, people who should know better. I mean,
William, you should know.
I should. I'm pink in the face.
Even the tool, even like Bash. I mean, at some point I was chasing some issue in GMP. It was like it would leak 2.5 megabytes of the Mersenne twistor in a buffer. And I didn't know where it was, so it was at a rather late point in time. It was like 1 a.m. I was slightly drunk, so I figured I'd screw it. I just read a shell script which Valgrinds every executable bit that is in the GMP test directory. And then just figure out, and I'm like, well, it was like 280 executables, and it turned out that a lot of them were shell scripts. And if the shell just instantiates, runs a little bit, and then leaks 80 kilobytes of memory, it's quite embarrassing.
Yeah.
It was fixed in Bash 3.1 mostly, but then Bash 3.1 had its own problems. If you remember that Maxima bug. So, but
I mean, libc isn't clean. I mean,
Yeah.
libc they do all kinds of.
Yeah, this is a standard.
yeah, but in that particular case, there's something called suppression, and what libc
Yeah,
and especially libstdc++.so does is lazy deallocation because it caches. But with the suppression files and so on, we don't see it. There's actually much worse offenders. If you ever Valgrind anything that is linked to the X server and use font caching, ooh, believe me. I mean,
But I have a question for a second. What do you mean by the Python garbage collector doesn't know about objects inside them?
okay, you instantiate a matrix filled with zeros,
Yes.
and you exit Sage. Well, an example is a 1,000 by 1,000 matrix over ZP. So the entry is like an integer or double. Then you have 8 megabytes of memory in a chunk that Valgrind claims has not been properly deallocated. But if you call the matrix A and you do del A and then exit Sage, it's gone.
But hang on, this doesn't happen for Python objects the same. Is it that Python doesn't clean up, says fuck it, when I exit I don't need to clean up anyway? Because I mean we're doing reference counting. I don't see why this should be different.
This is the bit, but this is the bit about nobody really understanding because we have like 3 layers and nobody sees the whole picture.
Last night we were looking at Perry. When you exit there's an object in the gen.pyx file that represents the Perry interpreter, and its dealloc method is not called when Sage exits. It just isn't called, even though that object gets reference counted down to 0.
But this is,
in theory.
there's still a reference because the module has a reference to that thing.
Yeah. In that
that's
case.
the problem.
Yeah.
It's not that Python garbage collector doesn't know about objects inside it. This is totally wrong.
No.
Are you sure that's wrong?
The Python garbage collector, I mean, it does reference counting and it does clean up objects. I mean, it's
Normally,
not like
yeah.
everything we
Oh,
write
yeah,
inside
yeah,
have
yeah.
to be free.
No, maybe he means that's only the case when the program is exiting.
It might, well, I didn't really have a look.
It's not always the case. This is not always the case.
No, but I mean, the thing is, remember when working at the discussion about it would leak if you allocate that big matrix filled with zeros, and if you did it over and over again, the mem consumption would climb and climb and climb. And then then I told you guys, well, just call del on the object, and then the problem's gone. So I mean, this might not be the most precise formulation of what I actually want to say, but there's definitely issues because what I did was you can import the garbage. You can import Python's garbage collection module early on in the process, and then you can turn on the debug option. And if you have PyDebug enabled at compile time, it tells you a whole lot of bunch about reference counts and so on. And that matrix object shows up in the garbage collection list. But there's somehow, the deallocate method does not get called.
Okay, have you tried this with a Python module, like a Python global, a module level variable in Python?
No, I mean, it's like I looked at it one night, it was 6 a.m.
I really doubt that this is a site issue. This is something, the module has a reference.
Can we come up with a simple example right now? Like, can you...
Like you say, you write a file foo.py, right? And this has like some variable, so zzi equals 1.
Okay.
And then, you input this at startup and then you exit. When you exit, the module is still loaded. So there's a reference. This is a module level variable. So there's a reference from the module to the variable. So the garbage collector. I'm speculating.
Yeah, okay.
The module holds a reference. So the garbage collector cannot say, well, let's kill the guy. Because my suspicion would be that Python says, well, fuck it. I mean, if we quit, we don't have to clean up all the modules and so on.
No, but Python does want to clean up all the modules. And actually, once it exits, it does tell the garbage collector, throw out everything there is. Everything you can deallocate. And it does that in a loop for a bunch of times. I mean, I took notes. I didn't have them with me. So, I mean, I can actually show you the code, the Valgrind output. And if I change the behavior, the problem appears. If I actually call del on that object, Valgrind tells me this is clean. So I mean, we should get into that like at Sage Day 6 when I did a little more research.
So is it maybe that when it exits, it does the allocation thing, but it doesn't bother telling the alloc on the object? It just goes through and cleans up its own heap?
I don't know. I mean, I literally need to spend 2 weeks with the Python source code and read it and try to understand it.
So it might be assuming that objects allocated themselves on the heap, in which case that would be a safe thing to do.
Yeah, it might say, I was asked to create an object, now I'm just going to get rid of the object.
Because I mean, calling dealloc can be really time consuming.
Yeah.
And it's really annoying if you try to quit Python and you have to wait 2 minutes.
And it could call other things, and then they could increment references. And
it would never end. It would be kind of annoying if when you try to quit Python, you get an infinite loop.
Yeah.
Yeah, this is pretty much work in progress, just understanding the problem, and which is probably much more difficult than actually fixing it, I hope. Because if we spend weeks and weeks of understanding it, and then it turns out it's pretty much like, well, Python 4 to fix it, it's kind of pointless.
Well, the point is that what Robert just saying is maybe you don't want to fix it.